Let's see, waiting for it to go live. Looks like we're just about there. All right, looks like we are live. So, all right, so welcome back to another stream. So, last week we did that exploring the STM32 stream, or the STM32U0 Discovery Kit. So today we're going to be back onto our ROS2 robot. And I believe where we left off last time was that we did the first major exploration of micro-ROS, and I'm trying to prevent my cat from eating my wires. As usual, she's the wire muncher. Oh god, there she goes. Okay, hold on, just a second. Sorry, what? Stop eating my HDMI cable. Alright, every time I touch it too, she's like, ooh, it exists again. Clearly I need to interact with it. Okay, hold on just a second. Let me turn my camera back on. Alrighty, so, where was I? Right. Okay, right, sorry, where was I? micro-ROS, we got it set up. We got it publishing laser scans over micro-ROS to our Raspberry Pi. And that's pretty much where we left off. It was figured out how to get, spent a lot of time trying to figure out how to get micro-ROS to compile. Needed to use Docker, or their Docker container, needed to do a couple of different things because we needed to modify things just a little bit because we're doing a Pico 2, not a Pico 1. But we did miss, it wasn't documented in the guide, admittedly, so I'm not going to fault myself for that one. But there is an option that we need to enable in that ColtCon meta file to enable thread safety in the data distribution service that micro-ROS uses, so we do need to go in and turn that on. And also, we used the laser scan message a little bit improperly. So if you recall, we did this. Here, let me go. Go in here. Let me close all these CMake lists. Close the transports, portable. Right. So if you remember the, what am I seeing here? Signal. Never mind. So yeah. So if we look at this LiDAR message, we did this whole thing where every time we look at a message, we update this minimum and maximum range thing. Turns out, don't do that. That's not what this is supposed to mean. This range min, range max is supposed to be, to my understanding, and maybe this is me being wrong again, but to my understanding, this is supposed to be the minimum and maximum valid range of the laser, the LiDAR. So if the laser can't measure less than 15 centimeters, set this to 15 centimeters. If it can't measure more than like 5 meters, set this to 5 meters. Basically the minimum and maximum valid range, so that any piece of data that you see that isn't that is automatically filtered out. And some of that crashing that we might have saw, where randomly the LiDAR would go off and start doing some weird thing, that might have just been it crashing from not having thread safety enabled on the data system, which means these RCL publish calls are not thread safe, even though we're calling them in a thread, a different thread than the executor. So that could have been bad. So we'll start with, so before diving into that, we're just going to start with one piece of, what is she doing? Okay, we're going to start with one piece of house cleaning, or housekeeping on the robot that we haven't done in the past. So up till now, we've been using the Pi Pico 2. The Pico 2W is what I had installed in here, but as we don't need wireless on the chassis, because the Pi will serve any wireless functions that we need, I'm going to swap this Pico with a... Why? Okay, hold on. Let me check my messages real quickly here. Okay, let's see. Oh, you know what? I forgot to connect my headset. All right, let me do that. Let me pair. There we go. Okay, perfect. Let me turn off noise canceling so I can actually not scream at the microphone here, because I'm want to do that, right? All right, so we're gonna take out this Pico 2W, and we're gonna replace it quickly with just a standard Pico 2. So that swap is easy. We just yank it out of the back because I socketed things. All right, it's out. Plug in the new one. Do that right quick. All right. Yep. That's not quite one. Seat. There we go. It's seated. Plug the USB back into it. And we should be good to go. Let me grab the debugger here right fast, just so we can flash the micro-ROS firmware to it. That is over here. All right, grab the debugger. Watch the cat fail to get onto the cat tree. Now she's in the middle one because she fell off the top. Okay, so I believe if I recall, it's orange to the bottom. See if these are wired the same way. That's SW clock. Well, we'll find out. Right. Okay. Hold on. Do that one. Do that one. No. Close enough. Let's route the actually let's route that cable a little better because we might want to use a debugger. That might be something we want to do. Okay. Got that plugged in. Route the cable. Bring that out here. Not cut the LiDAR wire on accident. Okay, cool. Yank this out here. All right. So we got the debugger. Pulled it out. And what are the cats after? Oh, that's fine. Plug the debugger in. Hopefully we got this thing wired the right way around. It'd be a little annoying if we didn't. I'll be right back. I gotta grab the USB cable. Alrighty. Grab the USB cable. Perfect. Alright, now we can debug. Alright, so got the debugger plugged in, got this plugged in. And what we'll do just quickly, just to make sure that we got some kind of firmware on here, we'll just do a quick, power this up, flash using SWD, as it's doing something. LiDAR spins up. Perfect. All right, so we've got micro-ROS flashed again onto this. Perfect. So that'll be good. Move these Arduinos out of the way. All right, so we've got our thing. Turn that off. Pi's going to be decidedly unhappy with me for that one, but whatever. All right, so we're going to come in here. We stir duped map. We're going to. I need to reply to this. I can do it. All right, this is probably going to be a short one today, just to get back into things a little bit. All right. So I believe the XV11 LiDAR minimum range is like 20 centimeters. Maximum range is like 5 meters. XV11 LiDAR ranges. What do we got? What is officially the range on here? Range doesn't really say. Milliseconds becomes another LiDAR effective range. Minimum distance Okay, well, we'll do distance. Minimum distance is 15 centimeters. Maximum is around 6 meters. All right. So what we'll do is set. So rather than doing this, range, publish, compute the min max, publish RPM. We don't want to do this range thing. The range is just, we'll set it up here. There's a scan ranges, intensities, angle min, angle max. End angle of the scan should be 2 pi. So 2 times pi. That was another thing we messed up. And then the time increment ranges. Sorry, this is in scan message lidar scan message dot. Okay, yeah. So we'll just copy these two, put this up here. We're gonna paste that. Range min is about 15 centimeters or 0.15 meters. I'll just say F there. And maximum is about 6 meters, so 6.0 meters. Let's see if we're just initializing this kind of in the right order, right? You know. All right. So scan time increment, scan time range min. Range min, range max, angle increment. Angle min, angle max, increment, time, scan, range. Okay, cool. Perfect. Ranges, intensities. Okay, awesome. So we did that. We're now going to delete this compute min max thing, as that was wrong. I'm going to only publish if micro-ROS is up. And then what else can we do? We don't want to accidentally clear any of this. Nanoseconds. Okay, cool. So that's what we needed there. So we should be able to build this, compile. All right, ignoring return value. We're just going to ignore the return value for now. Default is deprecated, use default 2. All right, support, timeout nanoseconds, callback, and then auto start. Timer and initialization. Well, how about we just leave it at the old one? Just for now. It's deprecated, but we'll just leave it for now. All right, compiled. Need to do some IMU calibration in the future, and then we'll do. Let's see. That's fine. We'll publish an IMU topic later. And then what we need to do is come into our. Let's while we're sitting here thinking about this, let's actually modify that. It's projects picobot, right? Pybot. Yeah, there we go. ROS workspace. No, that wasn't it. This micro-ROS Pico SDK. Yeah, that's what it was. History. Grep Docker. I need to start the Docker runtime anyway. Sudo RC service. Start. Docker. Oh, Docker start. Ha ha ha. All right. History grep. Docker run. Actually, what was still here? Wait, was the micro-ROS? What was this? No, it was in here somewhere, right? Built packages, CMake lists. Oh, micro-ROS library. That's what it was. Library generation. Okay, so history, grep, library generation. There we go. Docker pull. History. Micro-ROS static library builder. Jazzy. Oh, it's gonna take a while. Okay, hold on. Let's go back to the micro-ROS Pico SDK runtime. How do I build? Privilege net host. Oh, that's the agent. Sorry, how do I build? How did I build the thing, right? Yeah, present working directory, rod. Okay, yeah, cool. Change mod plus X, library generation. All right, so now what we do is we go to micro-ROS static library, library generation, colcon meta. And the thing that we need to change here are these two. That definition was done incorrectly. And then we need to do uClient profile, and then we go actually look up how I need to. So this is the micro XCRE DDS, I think. Yeah, XRCE, not XCE. Threading. Multi-threading, yeah, micro XRDDS client is uClient profile multi-thread equals on, and that should be fine. It might actually also freak out at us because we're not specifying which is not available on all platforms. Specific mutex is provided by each system. Support as following is provided. For other platforms, so how do I specify which platform to use? Well, I'm certain it'll freak out at us if it needs it, but it's not specified. So we'll find out here. You know, I wonder. Well, we'll find out. All right. So Docker run. Let's let that go. And remember that rsync error that we're going to get at the end isn't actually an error, it's just annoying. While that's building, let's see how we actually did teardown of micro-ROS resources. PB port, yeah, we got to actually fix that. Set up micro-ROS. I don't think we ever actually do a proper teardown. Set default allocator. As the main task kicks off. And the main task kicks off, does all of the setup. Yeah, and then just spins forever and never actually does teardown. Okay. So we'll just let this finish building, and it's done. Those errors aren't actually errors, which was what was tripping us up last week. So now we can look at lib micro-ROS. And that file wasn't updated at all. Look at that. It still says October 9th. Oh, the built packages is updated, right? Huh? ls include... message ls-l. Yeah, is this lib micro-ROS even different than the one that we built? Let's see. ARM Pico PyBot firmware dependencies micro-ROS. Those are not any different. It didn't change the build at all. So we're going to actually remove lib micro-ROS. Run that again, because it might not have wanted to update it. All right. Let's try that again. All right. So, well, that's again while that is running. Yeah, so we do that. That was the only major error. This will come up. Hopefully, the laser thing will fix our issue with RViz. And then oh, it failed. That's why it didn't update. Okay. All right. liblttng dlfc. Oh, yeah. Okay. I like at least it through error, so we can do something about something. All right. Deprecated API. Found T that cannot start any token. Okay, that's annoying. Okay, file formatting error. Right, and so we're probably going to have to specify a platform. In order, required folder shall be added to the toolchain. Oh dear. Okay. So how do I add free RTOS? Okay. They don't define. Oh, right. It's that stupid thing. All right. So we're going to have to figure out. Maybe that is supposed to just be you. That doesn't seem correct, you know? My custom toolchain.meta. My custom. All right, well, anywho, we're going to look at this GitHub page, and maybe we can find in the CMake file what configuration options we have. Micro client, do stuff, string equal. Let's see here. All right. Serial transport. Yeah, so the mutex multi-threading is not supported on this platform, which is fine. Which, yeah. Yeah, because it probably doesn't know which. Yeah, it doesn't remember. It probably doesn't know what platform that we're running on. So let's figure out how to set the platform, right? Yeah, so free RTOS. So CMake system name generic. If platform name free RTOS plus TCP. Well, I don't want that necessarily. Okay, well, we'll just we'll see what happens. So we'll do vim micro-ROS. No, not extra packages. Sorry. We'll edit our colcon meta here. We're gonna do, or actually, it's the toolchain that sets this. So toolchain.cmake. So we set system name as generic. We're gonna have to say set CMake platform name as, what did it want? Free RTOS plus TCP. Yeah. Free RTOS plus TCP. And that's just platform name, not a CMake thing. So we'll just set that here, I guess. All right. Now let's see what happens. we gotta do that change mod thing again. Okay. Run that. Let's see what happens. Hopefully this builds. We might have to feed in the free RTOS headers, though. That is entirely possible. And we'll see what happens. Well. Yeah, there we end up. We're not supported on this platform. Free RTOS.h is not found. So probably, yeah. All right, so we're gonna have to drag in the free RTOS headers. All right, that's fine. Also, how or well, let's see. Trying to remember. I'm going to drag in the free RTOS headers. And we can do that by... Honestly, we probably just... Okay. Well, this is going to be a little complicated. So, okay, what we'll do is it's going to pull all of this stuff. Free RTOS config. Is that new? No, that's been... Oh, is that my free RTOS config? It could be. That could be the one I stuck in there. Okay, so... Vim, micro-ROS, static library generation. We're going to have to edit some things here. Library generation, extra packages. We might just do adding extra packages workaround. Gonna have to pull free RTOS files. And we're going to make sure it's the same version of free RTOS we're using over here, otherwise things are going to be really nasty. So we go deps, free RTOS kernel, 11.2, git log. When did this come out? March of this year, which is a while ago. Anywho, we'll make sure to pull, pull free RTOS files, make their, well, actually we don't have to do that. Git clone the 11.2.0, https, github.com, free RTOS / free RTOS kernel, just git remote, yeah, git kernel, push d, actually, and we're also gonna what, recurse submodules. And that should just give us free RTOS. But we're also going to need to... That'll be in the firmware MCU workspace folder. And... library generation, toolchain, project, micro-ROS static library. Change directory to micro-ROS workspace, source. Honestly, let's just not worry about it. HTTP git clone b 11.2.0 recurse submodules https github.com free RTOS kernel 2/ free RTOS kernel. Yeah, that'll be, just make that easier. And then the thing that we did here was dependency, or sorry, was cat CMake list. What am I doing at here? I could just open it up like a normal human being. Okay, so we'll set the, so we know that we're in the tool chain. Micro-ROS tool chain, we're going to do some stupid things like set free RTOS, free RTOS path. What is path or kernel path? I can't remember. Free RTOS kernel path as CMake current lister. No, actually, sorry, what am I even doing? Stupid slash free RTOS. That's where we put it after all. Free RTOS kernel. Set. Actually, do we even need that? Maybe we can get away with doing that. So where is free RTOS.h? That comes in the include folder. So what if we just said include directories, which is a bad thing to do, but we don't have a target yet, so we kind of have to. Include directories slash free RTOS kernel. That's disgusting. Well, oh, slash include. And we might need a, probably gonna need a free RTOS config, but let's see what happens when we run this time. Oh, stupid. Need to fix that. All right. Alright, waiting for this to build again. Probably gonna need to give it a free RTOS config, but that's fine. We'll deal with it when we get there. Alright, deal with it when we get there. Perfect. Wonder if these set anything interesting. Like if we did free RTOS kernel, portable, third party, community supported ports, GCC, ARM. Do these set anything fun? Okay, what errors do we see? All right, yeah, error not supported on this platform. Free RTOS config not included correctly. Yep. All right. Well, we need a free RTOS config, so we might as well just bring one in, right? What? We put this in the slash project folder, right? So what if we did oh, this is gross. We're just trying to make this work. We're just trying to make this work and then see what happens, right? That's a stupid thing. All right. We'll make this cleaner once we get it to at least work once, right? That's how we always do things, right? Okay, so we should probably set free RTOS kernel path, and then what else does this set? Oh, it doesn't set anything. Okay, that's fine. Includes library CMake. library CMake kernel core. Are there any sets that we need to do? Doesn't look like it. That's cool. Let's see what we get on our thing here now. Port macro. Yep, port macro is not happy. Find name port macro.h. Let's see. Oh, ew. Third-party community supported ports, RMNTC non-secure port macro. Okay. It definitely wants that. Okay. Yeah, the whole thing is that, you know, normally we would try to add the in a standard CMake environment, right? You would add the you'd add the DDS to your project, and you would then add you'd add FreeRTOS to your project and the DDS to your project and pull the headers from that. But we're not operating in that environment, unfortunately, some reason. Also need to figure out why multithread.c is saying that multithreading is not supported on this platform. So maybe we take a look at that too. Just, we know we don't have the, well, actually, do that in a second. Let's finish adding the port headers, right? Non-secure. All right, so we'll also do include directories, FreeRTOS kernel, portable third party. Well, it's not a little bit more. Yeah, community supported ports, GCC, RP2350, ARM, and TZ. Oh. / non-secure. Probably because I don't know if FreeRTOS supports trust zone on the RP2350. Interesting. Okay. Now, let's also set the kernel path just to be friendly, right? And we'll just be perfectly kind, and then we'll do FreeRTOS kernel path. And FreeRTOS kernel path. Include. Okay, cool. Change mod, docker run. And then we'll try to figure out what this multi-threading not supported. So that's in source, C, profile, multi-thread, multi-thread.c. Okay. Okay, well, maybe it's failing because... Oh, platform name FreeRTOS. Why is that not defined? Who defines FreeRTOS? I mean, that's in this top-level CMake, right? Oh, that would be really annoying. Okay. Oops, I spelled that wrong. FreeRTOS. FreeRTOS plus TCP. How do we get... client platform plus TCP. If defined platform name FreeRTOS. If defined platform name FreeRTOS. How do we get platform name FreeRTOS? It looks like It doesn't look like it's added anywhere. Interesting. Let's see what this does. Yeah, you know what? Let's just globally add definitions to do define but not use pico.h. Oh. Pico.h. Oh no. Well, now we're going to feed it the Pico SDK. Oh. Yeah, I figured. Okay. That's probably gonna end up over here. Find dot dash name pico.h. Nope, because we don't have the SDK checked out here, right? Okay. Okay. Where would I have the library checked out? It might be in here. Okay, fine. I did that wrong. // pico SDK dash name pico.h. Okay, include boards pico.h, base headers pico.h. Well, this is brilliant. Okay. Full chain. Not liking this. Include directories. Pico SDK. Again, this is just to make this work. We'll try to make it cleaner in the future, right? We'll do add definitions, platform name FreeRTOS, right? Platform name FreeRTOS. Yup, and nothing ever actually defines it. Issues. How long ago did this? Users in charge of defining platform name FreeRTOS. Interesting. Okay. Just to make sure I remember how this thing works. Add definitions. CMake. Okay, and that is that. Okay, cool. Pico base headers. All right, let's try this again. Building. All right, maybe it'll work this time. Probably not, but maybe we'll get lucky. Oh, actually, I don't think it's the part that was failing. Yeah, it wasn't. Okay. Oh, it won't work because project source no such file or directory. Oh, wait, no, it did work. It's just pico version.h. Dang it. So close. Wait, what? Huh? Version.h. Uh-oh. That header might not exist. Okay. Source include. Horse. Common. Pico version.h. Pico version.h.in. Oh, crap. Okay. Auto-generated, don't edit. Alright, this is getting complex. This is getting more complicated. Okay. We're going to do our own custom build of XCR, whatever the hell. XRCE. Brilliant. Okay. What might we do to make this easier? Pico SDK version string. You know what? You know what we can do? We can bundle stupid stuff like copy our own projects version.h, right? No, that's too evil. Okay, hold on. Besides just being dumb. Okay. This because we're not editing, we're trying not, I mean, we don't have the ability to edit, or we do, but easily don't have the ability to edit, you know, this is supposed to be a toolchain header, not adding libraries, right? Oh, dear. Hopefully nothing else. How much more are we gonna get out of here? Anyway, Pico.h. What else does it include? Pico types, Pico config, Pico platform. Okay, we might be able to get away with this. Okay, so if we copy the latest, what do you call it? We're copying the latest SDK, so let's copy Pico, or copy ARM Pico PyBot firmware. Let's try to find this Pico version in there. Find -name version.h. There we go. It's auto-generated, but fine. We'll copy the whole Pico folder to here. Yeah, there we go. That'll work. And then we can edit out the, including the Pico SDK, because we've pulled, actually no, we need that one, but project will be fine. So change mod, maybe it'll work this time. Realistically, the best way of going about this would be to edit the CMake list for micro-XZ stuff, micro-XRCE, but just not going to get into that for the moment. The toolchain for micro-ROS, the build system for micro-ROS already feels extremely fragile as is. The only thing we're really linking against is the headers. We only need the headers because we're compiling this separately, right? Ah, shit. Okay. No! Something got pulled. Config auto-gen. Okay, well, we can hack up the auto-gen header then. Oh, dear. to slash Pico SDK. I gotta make this easier for people at some point. This is ridiculous. Or I'm completely out of my element here. Or I'm completely barking up the wrong tree here. Something just doesn't... It just feels wrongly difficult, right? Platform.h. Missing platform.h. Okay. Well, we're working on it. No, it won't be in there anyway. And actually, we don't want the Pico W, we want the Pico, because that's what I'm using now, right? And we need to do the RP2350 version of platform. Because of course we do. And actually, we can do multiple include directories in one. It's directories, right? Not in directory. We can always, at least let's make this one line per project, right? Okay. I could fix the tab stop, or I could not fix the tab stop. Okay, perfect. Change mod, Docker run, right? All right. Let's see how this one does. All right. Extremely resource constrained environments. Let's see. And it's provided by ROS2. See quality declaration. It's crazy. I have to figure out how to dependency inject this thing so we can like shove the free RTOS binary into there. Kind of surprised it already doesn't link to free RTOS, but what do I know? Weird. Almost back to seeing what happens. We just need the core. Geometry. What did we not include this time? What red text? Ah, yes. There we go. Pico platform compiler. Compiler.h. RP2 common. Okay. What IN file are we going to end up with for this one? Who knows? run. All right. You know what I really could actually be doing is just opening all these include files and seeing where whatever headers it includes are, so I don't have to keep running this over and over, because it does take a little bit to set up the compilation environment. Out of Docker, because it's rebuilding part of the container every time. Let's see. All right, continuing along. Geometry, we'll find out pretty soon if we need more stuff. Yep, we need more stuff. Platform defs. Okay. We're just going to change mod. We're going to was platform defs, right? Platform defs. Okay, RG. No, finds. Yeah, hardware regs include. And we're just, this time we're just gonna see what's in here, see if there's any other places we have to include. Oh, it doesn't actually include anything. That's nice for this one. Hardware, RP2 common, compiler, include Pico platform compiler, platform defs. Okay, there's that. That one's fine. Alright, well, let's wing this again. That's probably, we dug down into that one, so there's no more in that tree, but maybe there's a top level that pulls subdirectories again. But we'll see, See what happens. So yeah, behind me you can probably see my new workbench setup that I've done since the last time I streamed in my office here. So I'm gonna be able to build some fun stuff there moving forward. Yeah, I wonder if GitHub's throttling me for pulling the same repository over and over again too many times. They do that. Alright, doing some of the tools, and then hopefully we'll pass the build this time. Ah, shit. Okay. Pico platform sections.h. Okay, we're gonna try to do a better job at directory searching this time. Alright, platform sections include. So I'm gonna try to figure out that platform. Sections, panic, common, hardware regs, address, SIO. Okay, we're just gonna make sure that we got find. Well, I already forgot what I'm looking for. Panic, common, and then address map. Panic, common, so we're definitely going to need to add platform panic. It doesn't look like we have platform common included either. Common, and then address map. That's 2350 hardware regs include. We might have already got that. Hardware regs include, yeah, we already got that. So Vim, let's see what's in here. No includes, which is nice. And panic. Also no includes in here. Okay, maybe we'll get further this time. Do. I'm feeling I fucked up my visibility here. On the stream. I mean, I had one person come over here. Anyway, that's whatever. Okay, let's see what happens now. Ah, crap. Hardware sync port macro. That it's a new part of the tree though. All right, hardware / sync.h. Nice port macro. We're back at this file, seeing what it's including. Copy. Vim. Hardware sync. Okay, hardware sync, port macro common. Okay. So find sync.h. Those are probably the intercore FIFO type things. Yeah, hardware sync include. The real question is, what does this actually include? Hardware address mapped. So find dash name, find, wait, hold on. Address mapped. Hardware base include, yeah, that would have been another one. Okay. Address, hardware regs, address map. We've already pulled in here, right? Hardware regs, address map. Find. Hardware regs, address map, right? We already have that. Hardware base, hardware regs. Yep, we got that. So that should be the rest of the stuff in hardware sync, and then we can do port macro common, right? What's in here? Looks like nothing, or no include. Sorry, maybe we're close. We got to be close, right? All right. It's the most gross and horrible way of doing this, but if it works, it works, right? then we can make it cleaner into the future, right? Okay. Beep boop. Yep, getting throttled by GitHub. Throttling me to 50 megabit. Or something. All right, maybe. We're close. I feel it. We're close. Okay. Oh, shit. Okay, what? Address mapped. I missed that. Where did access control come from? What? Where did... Okay, that's on me. Where did that come from? Address mapped. Access control. Way down at the freaking bottom. Okay. Oh, we also might have to define Pico RP2350 to make this go through correctly. RG. Yeah, we're gonna have to define. Probably gonna have to define that. Define RP2350A1. Well, maybe... Maybe it's already defined? I don't know. If... Pico RP2350... Bunch of these headers that might not... Well, we'll see if they work, right? Sync spinlock.h. If... Well, alright. Well, we'll do that. Wasnet. Set default. Interesting. Interesting. Well, we'll define that. Hardware structs access control. Okay, RG. Access control. Probably did that wrong. Yep. CTRL. Hardware regs. Hardware structs. Yep. Okay. We're going to add definitions. Pico RP2350 and Pico RP2350A. Because we're doing a board Pico board, Pico 2. Yeah, Pico platform. So, oh, wait. Messed up. Hold on. -D. -D. Now what shenanigans are we going to get ourselves involved in? Docker, run. Okay. We're trying. I want to say we're close, I can feel it, but, you know, given a sample size of no successes so far, but a lot of failures, you know, it's probably not going to work just immediately, but it only takes it working once, right? It only takes... If we can reduce this to practice... actually, this might just be the cost of doing file system through Docker. How to build the base stuff first. And then here we go. Let's see what we forgot this time. Yup, hardware sync spin lock. And that's because I defined shit, right? That's oh, that's not good. Size of expected declaration specifiers. Well, maybe it's because this spin lock thing isn't getting included correctly that it's blowing up in my face. That spin underscore lock, yeah. Yerp. Tool chain. All right, let's see if what it decides to include. Hardware sync, but we've already included that. Anything at the end this time? Nope. All right. Pico use spin locks. One and okay, cool. Sure, why not? Change mod, Docker. Hey, don't know what includes we're missing now, if any. We'll find out. Okay. Maybe, just maybe. You could also just be totally barking up the wrong tree here, because there's a bunch of macros and stuff that define the Pico SDK build chain that we might not be correctly setting, or probably not correctly setting up. And then when we go to link it with the rest of our project, who knows what will happen. And while we're at it, while we're just waiting for that, let's just come in here and change our Pico board to just Pico 2. All right, geometry. Let's see. Ooh. Oh, ah! It got closer. But this size up thing is now happening, and that's bad. Expected declaration specifiers or ... before size of. Which means that either static assert is failing. At least it's no longer include problems, right? But an expansion of macro, ISO C++ forbids brace groups because it's compiling with W pedantic. Just fine, but it's this size of address that there's probably a macro not defined that's causing this type not to be defined. So let's try that. Or let's see. So if we look for yeah, because here we go. Access control, hardware T. Oh. It's all here, yeah. But the problem is that a bunch of these might not be defined correctly. because access control base. Yeah, because address mapped. Let's go look at all these headers that we were goofing around with before. Like, if Pico 2040, if not Pico 2040, then access control. We already included access control. Let's look at address map. Did we ever open address map? Probably not. Let's see. Platform depths. Let's see. All right. If 23A, else that, if 23A, cores. The question is whether there's something that's not ifdef. Findef risk v, risk 5. It's not risk 5 because it's yeah, honestly, it's pretty cursed trying to do all this stuff without the Pico SDK. But pretty cursed. Did you mean? I wonder if we didn't static allocation. We do want to enable. I'll come over here and make sure to enable it over here as well. We fixed one thing. Hooray. So why is this happening? In spin lock expected before size of. You know what? Maybe we just copy this into Claude and see what it says. Because I'm at a loss and I'm trying to move forward as fast as I can, right? Can we use is that a valid use for AI? All right, let's see. What does it say? It says set stand. Oh, I might not have set the standard. That would be funny. Toolchain. Well, we didn't set the. Oh, we did those. SC11, but that's in the compilation. Well, that's in the compilation flags. That should do it. That should do it. That should do it. Now I wonder if X whatever here is doing a C99 compile. Look at that. C standard 99. C standard. Uh-oh. Uh-oh. Well, we need to add something to our meta colcon then. C standard. Does micro client, do we set anything regarding the standard here? We don't. So we're going to change this to 11. We're going to turn it up to 11, eh? uClient C standard, right? uClient profile, uClient pick. Wouldn't we want position independent code on? I don't know why it's turning it off, but anyway. But yes, we ought to not do that. We ought to do du client C standard equals 11. C underscore standard equals 11. du client C standard 11. All right. All right. Maybe we'll be free this time. See what happens. And maybe we'll be okay with free RTOS there. That since we enabled static runtime, right? Oh. All right. Hey, Danish. We are attempting to correct a problem from last time where we essentially didn't enable multi-thread support in... Sorry, we didn't enable we didn't enable multi-threading support in micro-ROS because the usage guide made no mention of turning it on, but in one of the libraries used, I noticed that there was a flag to turn on multi-threading support, and there's a lot of things that are not working when I try to enable, or there's a lot of things that aren't compiling when I enable multi-thread support. So we're going through and trying to figure out how to force the toolchain to build, there we go, more crap, more broken crap. Trying to build more multi-threading, oh, I broke the stupid, sorry, formatting. I need to just eventually override all of my Vim tab spacing stuff to fix it globally, but whatever. Yeah, so if I go in there and I added the flag to turn on multi-threaded support in the runtime for... What am I, a Taylor? Yeah, right? Well, the whole thing is that I think they may not have enabled multi-threading support because all of the platforms they typically run micro-ROS on don't have more than one core. So even if you do run multiple threads, because of the environment that you're in, you never have parallelism problems. You might have concurrency problems, you know, where a thread gets interrupted and then it tries to go do something else, but you'll never have two cores in parallel trying to access the same piece of data. So, because the Pico is actually somewhat unique in the fact that it has more than one core. But, so we're trying to fix that. We're trying to enable the multi-threading flag, and it's been a journey. So maybe it, we've hacked a bunch of stuff into the toolchain, so, all right, let's see. We're to the point where it'll fail if it's not quite ready. It's going. It's doing more than it's ever done in this stream so far. It might, oh. Dang. Firmware might, oh, we did make it further. Okay, we made it to a different library. Access control. Yeah, looks like we static assert. Okay, that is the C runtime not being the correct one for this. So Mike RMW CMake args. So we need to figure out how to force RMW micro X RCE DDS. Okay, we need to figure out how to force the C version in this. Because if you do the C standard, here we go. Haha. Okay. Because the Pico SDK assumes C11 compliance. But a lot of these tools are just doing are defaulting to C99. Which, to be fair, there are a lot of embedded compilers that don't have C11 compliance, even though it's 2025. So we're working on it. All right, maybe this will do it. We made it far past where we had been stuck up to this point. So we'll get in here. All right, Pico SDK, cloning the FreeRTOS kernel. That's what C++ is. It's one greater than C. No. Look. C3. I mean, there's K8. K8s. C plus equals. Alright, let's see where we get this time. ROS IDL, unused variable error string. That's fine. That's fine. Where do we get to? Let's see if we make it to the end. It'd be cool if we did, but we might not, because you never know. But we've never made it this far, so I'm hopeful. Did it work? It worked! Oh, finally. Okay. Well, it compiled. Whether it works or not is a completely different question. Alright, so we have our new lib micro-ROS. Okay, so we'll delete projects, ARM, Pico, PyBot, firmware, dependencies, lib micro-ROS, copy, lib micro-ROS to projects, ARM, Pico, PyBot, firmware, dependencies. Okay, deps, lib micro-ROS. Okay, perfect. Now let's see if we can actually fully link the project, right? Clean. Oh, oops, whatever. We're gonna nuke the build folder here. Delete, and then compile. We'll do compile. Linking might be a problem. We'll see if it links. Yeah, it didn't link. Of course it didn't link. Undefined reference to vapplication get timer task memory. Vapplication. Create idle tasks. Idle task memory. Okay, that might just be in X timer create timer task. Interesting. FreeRTOS config. What do we got? Maybe we didn't enable timers. We did use timers. How about idle task memory. Okay. Well, that's kind of annoying. No, ew. What? Okay, so FreeRTOS tasks.c. Something ain't right. Oh, well, we did say support static allocation. So that hasn't been enabled before. So we're missing something. Else, get idle task memory, idle, passive idle task memory. Okay. Let's see. What do I need to do? Oh. Well. Disable static allocation. Well, you know, I'm just going to copy the response that Claude gave me, which is, turns out in FreeRTOS, if you do this get idle task, if you do static task, you do have to provide hooks to support allocation of some of the static resources. If you're using with both cores, make sure you have number of cores is set to 2, and passive idle hook is set to 0, which it is, so that's fine. Okay, so main, we'll just do this FreeRTOS thing real quick. Please ignore me for using AI. I'm a horrible person, I know. All right, where's this if-def thing? Of course, we have more than one number of cores. Okay, well, we'll copy this, and just because we're not stupid, we will step through what it says. Idle task, application get idle task memory. It is a hook that needs to return the static, basically the memory for the idle task, which here's memory for the TCP buffer, which is allocated here, stack buffer. We've defined the idle stack size as config min stack, and then stack size is that. Same thing with the passive idle task if using SMP. And the same as with the timer stack. Okay. That's pretty straightforward. I'm not particularly, what do you call it? Fluent in FreeRTOS on some of the, I haven't done the static form of it yet, but let's see what happens. Compile. Do we link? We still failed to link. Undefined get timer task memory config use timers. We do have config use timers on. Yeah, we do have config use timers on though. Define reference to v application get timer task memory. But we did define it. So how about we just delete these if-defs here because they're all true. Okay, let's see what happens. Compile. Failed to link because of in function timer task create undefined reference to the application get timer task memory. Oof, it's still not happily linking, which is unfortunate. But we did define it. Did we need to include? We already included task.h. Oh, it's, that's why. These all need to be extern C, probably. Because this is a C++, not a C file. And it's tasks.c, probably, that's asking for it. Yep, that's probably what did it. Compile. Yep, that did it. Okay. That is why. Okay, and see, AI did not give me the completely correct answer. I had to think through it myself. Okay, so, well, it linked. So let's see what happens if we flash it to the hardware now, huh? Does it still work? Turn that on. Pico, flash over SWD. See if the LiDAR comes back up afterwards. Yeah, any key to close. And let's see, if we power this up. It booted. We'll hold our breath until the Pi comes up, and we can try to launch the agent. I'm gonna have to be done here in a second. I promised somebody I'd do something this evening. All right, so let's see here. All right, we need to sh pybot.local, right? Was it pybot or was it yeah, it was pybot, right? Yeah, or no, it was term equal stinger, not pybot. Okay, well, let's see if we can get in now. Yes, we can. So now we need to do source. Well, actually, yeah, because we're doing the doing Jazzy. We're going to the micro-ROS. Is the micro-ROS workspace or the ROS2 workspace? Micro-ROS workspace, probably. Okay, source, install local setup, and then we were looking at build, or... Yeah, this stupid thing. But ROS2 run micro-ROS agent. Micro-ROS agent, serial dev tty acm0. And it's up. It didn't blow up yet. So let's try to run rviz. Now I got to do the xhost plus thing, right? Xhost plus. Cool. I should be able to do rviz too. Yes. Okay. And then if I do a laser scan, I should theoretically be able to look at laser scan. And it's not scanning. Showing 0 points. Because of course it's showing 0 points from things. But no TF data. Let's kill that. Discard. How about we do a ROS2 topic list? Yeah, we're not actually... Oh, there we go. To topic echo laser scan. That's not publishing anything. How about we do pybot firmware LiDAR RPM? That's not publishing anything. That's bad. Looks like something's not right. Well, shoot. Now how to go about debugging this? How would one go about debugging this? Alright. So it's entirely possible it just fell over trying to do this multi-threaded version of micro-ROS here, but I don't know if it is or not. It could be sitting here forever. It might not be. Who knows? Laser scan message. 2 pi. Well, shoot. It doesn't actually seem like the PID loop for the laser scan is working if I poke the LiDAR, so I don't think it's actually working, unfortunately. That's unfortunate. It got stuck somewhere. Well, because it got stuck somewhere, well, you know what? Let's reboot the PyPico itself and then see. We're gonna close this, and then we shall. Yes, we'll plug the debugger in. We'll reflash micro-ROS. Well, our micro-ROS project thing here anyway. We'll run the agent. We'll echo the RPM. Oh, you know what? Maybe it was fine. Maybe it was actually just okay. You know what? It was because we'd spent more than 90 seconds getting the thing up, probably, and it's probably because it's probably because we spent more than 90 seconds getting up and it timed out on connect. That's might be what I'm gonna choose to believe that's what happened. I'm gonna oh, oops. Yeah, I need to flash that. Or at least reboot it, right? So we do that, boot the agent, and then we're going to run RViz. And then we'll add a laser scan from /laser scan. And we get our laser scan. Woohoo! All right, we haven't completely buggered it. And notice... Notice something that has changed since last time, and that's that if I put the thing in the middle of the floor, we don't get those degenerate points that we used to get around the middle, right? It's now actually filtering out the points that it wouldn't have otherwise been able to see. Where am I in here? I'm on the left. That's my foot, the green right here. Okay, so I think it's actually, yeah, what I can't remember what the axes in here are. Maybe if I say grid, if I do a TF renderer, right, add TF. No, nothing's publishing transform though. Oh, that's fine. If I point this at a box, right, we'll be able to see what axis in it. Yeah, so this is the box dead in front of it, and I think this, I don't know if this is, I don't know what what we were looking, right? Yeah. It might be forward. Yeah, because the laser's technically rotated, right? So, I think we turned it to the right. I don't actually know what that means. Okay, so clearly getting laser scans. We're getting laser is okay. We're 5 hertz, which is what we want. And okay, yeah, so that's good. Cool. We got our micro-ROS compiled with multi-threading support. In theory, I don't. We're gonna have to figure out if RMW, if free R, yeah, that doesn't actually say anything. But we have to figure out at some point maybe how threads increasing static pools of dynamic allocation. Who knows? what am I trying to say? I am trying to say that we don't necessarily know how it makes use of the threading stuff under the hood. We just have this just option that we enabled. Maximum number of guard, weight conditions. I just don't know, right? But we could try to dig into this at some point and see what exactly it's doing with the micro XRCE DDS. Because the question is, like, how is there anything is there anything that would otherwise need to have lock, guard inside of RMW? But we're supposed to only use RMW from, or we're only supposed to use at least the ROS setup constructs from the thread that spawned the agent, but we just don't know. So, who knows? But I think that's where I'm going to leave things for tonight. Now we're just going to, usually this should be where we're going to start. But yeah, I'd made some promises to some friends about some stuff I do this evening. So, leave it here. So we fixed our mistakes from last time. So we're going to have to do a micro-ROS part 3 next week. Or actually, I take that back. We'll do it, am I doing anything Thursday? Let's aim for doing something for I swear I promised something on Thursday. What did I don't think so. No, I don't have anything on Thursday. Yeah, so we'll pick back up with this on Thursday. Just because I'm swamped on time tonight. But yeah, we'll pick this up on Thursday. We'll actually go through and implement the rest of the sensors, and we'll try to implement the motor so we can start driving it around through ROS rather than just driving it around through Wi-Fi directly to the chassis controller, because then it would be maybe we even directly connect the controller to the robot, but we could do controller to the Pi then controls the Pi Pico through micro-ROS, but a little more implementation is required. I'll also try to clean some of this up and maybe get this up on GitHub, so that y'all can actually start seeing what's going on, or well, have something to work off of. But yeah, we're also going to need to, another thing we need to figure out at some point is a reconnection on the ROS agent, so that I don't have to do that thing where I try to reflash the, anytime I need to restart the Pico, I have to reflash the thing. And also, I'm pretty sure the MPU is probably going to want pre-fused data and just get raw acceleration and gyroscope values and have ROS do the correction. But maybe we don't. Who knows? But anyway, we'll do that next week. We fixed everything today. So yeah, we'll pick back up with this on Thursday. And so for anybody who's been through the journey with me tonight, thank you for watching. Please, if you're interested, just please join back Thursday. Should be when we get this stuff good to go. All right, let me turn off my stream here.